tutorial on how to use Excel in chapters 3.4, 5.1, and 5.2. So in 3.4, we were introduced to permutations and combinations. Suppose you had the following: evaluate 41 permute 2. So to do this in Excel, the function we're going to use is equals PERMUT. So it's just one letter shy of permute. I don't really know why they did this. In any case, make sure that you use the correct one. You do not want to use the one below it, right? That one actually says permutation. That gives you something else. The parameters you need here for permut are the number, the total number of, the total number in the sample space, I guess we can say, and then the amount that we're choosing. So there's 41 in total, and we're choosing 2, or we're permuting 2. So 41, comma 2, meaning 41 permute 2. Hit enter, and that gives us 1,640 different outcomes. Now for combinations, suppose we had evaluate 45 choose 2. The function is equals combin. The parameters, once again, are the total number that's being considered and the amount that we're choosing. So 45, and we're choosing 2, so comma 2. Close the parentheses, and that gives us 990. Now for chapters 5.1 and 5.2, we're actually going to take a look at some homework problems. Notice that both of these chapters are actually grouped together. They're actually the same thing. The only difference is that in 5.1 we have z-scores, and in 5.2 we do not have z-scores. So let's take a look at problem 1. Suppose we want to find the area to the left. So to the left of z equals 1.86. The wording is, you need to be very careful with the wording, right? Sometimes you want to find the area to the left or to the right, or even between two different values. So here the area to the left of z equals 1.86. Forgot what I said. 1.86, sorry. Okay, so note once again that we have a z-score. Since we have a z-score, we're allowed to use the standard normal distribution function in Excel. So note, because we have a z-score, we're able to use the following function. And I guess before we begin, the function that's built in Excel, it only calculates areas to the left of z-scores. So luckily for us, this first problem we're working on, that's exactly what we want, right? We want the area to the left of the z-score. And again, that's all that Excel can do for us. It's not built to do anything else, at least with this function. So it could only find areas to the left of z-scores. The function is equals norm.s.dist. So the S here stands for standard, so it's the normal standard distribution. We need two parameters. The first parameter is the z-score, which we already have, 1.86, and then we need to determine whether we want the cumulative distribution or not. So the z-score, 1.86, comma. Now for the cumulative distribution, we always want to put true, because we always want the area to the left of any z-score. Therefore, this value should always be true to ensure that it's giving us a total area to the left. Hit enter, and it looks like the area rounded to 4 decimal places is 0.9686. Okay, fantastic, cool. Now suppose we have a different type of problem. Suppose we were asked to find the area to the right of a z-score. So to the right of 1.67. I'm sorry, this is z equals 1.67. So once again, the function we're going to use, it's still going to be the same one, norm.s.dist, but keep in mind that this function only finds the area to the left of any z-score. For this next problem, we want the area to the right, so we're going to use the technique that was introduced in the book. The way we're going to find the area to the right is we're going to have 1 minus the area to the left. Doing that, again, we're taking the total area, which is 1. we're subtracting the area to the left, and that's going to leave us with the area to the right. We know how to find areas to the left using Excel. That's norm.s.dist. Once again, the parameters we need are the z-scores, and then if we want the cumulative distribution or not. So 1.67, comma true. Again, this is always going to be true. Hit enter, and that gives us the area to the right. So it looks like the area rounded to 4 decimal places, 0.0475. Cool. All right, let's jump over to problems in section 5.2. I believe they begin in question 6. So here we have assume the random variable x is normally distributed with the mean of 84 and a standard deviation of 4. Find the probability that x is less than 76. Okay, so before we do anything here, notice that we're given a mean, we're given a standard deviation, and an x value of interest. The probability that x is less than 76. If we do this by hand, we know that we first have to find the z-score, so we have to convert 76 into a z-score. And then from there, we're able to apply use the table that's given in the textbook. So what we want is the probability that x is less than 76. Again, if you do this by hand, we would have to convert x into a z-score. That z equals x minus mu divided by sigma. And again, we're able to use this formula here if you do this by hand because we're given mu, we're given sigma, and we have the x value of interest. But now here in Excel, we need to use a different function because we don't have a z-score. So keep in mind, we do not have a z-score. So since we don't have a z-score, we need to use a different formula, or function, a different function in Excel. Now the function in Excel for values that are not z-scores, it's actually pretty helpful because Excel is going to convert this value into a z-score and calculate the area to the left at the exact same time. So it's pretty much killing 2 birds with 1 stone. Whereas if we do it by hand, we first have to convert it into a z-score. Once we have the z-score, then we need to use the table in the textbook to find the area or the probability. So now the function we're going to use here, because we don't have a z-score, is equals norm.dist. Notice it's almost similar. The only difference is that we don't have the s in the middle. So just norm.dist. Left parenthesis, notice we need a few parameters. We need the x value, we need the mean, standard deviation, and whether or not we want the cumulative distribution or not. So we know the x value is 76, right? Now we need the mean and the standard deviation, and that was given in the problem. The mean is 84, standard deviation is 4. So mean is 84, comma 4, comma, and then true again because we want the cumulative distribution function. Okay, so the probability that x is less than 76, once again, this function here is going to convert this x value into a z-score, and at the same time, it's going to calculate the probability. So that's really nice. Hit enter. It looks like the probability, also known as the area, is 0.0228 if we round off to 4 decimal places. Check answer, and there it is. Okay, so I hope this video helps. Once again, feel free to use these and also feel free to ask questions. Thank you.